Welcome back to Meson African Motifs, still on our mathematics for N2. And this is going to be a platform for a revision working with the introduction that we are going to have on our exponents. As we understand that exponents is all about the laws that you're going to work with. In each and every part, you are going to work with the exponents. All right, so in this case, I want you to understand the laws of exponents. All right, it is very, very important that you work with your laws of exponents in the simplification of the exponents. All right, so let us consider the exponent that we are multiplying the bases which are the same. If you are given this situation, x to the exponent of m, we are talking about x being the base and m being the exponent. So it is representing the exponent, the index, or the power. So when these are being multiplied, it is same like we are given 2 to the exponent of 7 times 2 to the exponent of 8. You can actually be working with bigger values where you can simply need to apply the laws to simplify that, or maybe you're working with the letters where you have got x to the exponent of 3, x to the exponent of 9 being multiplied together. There you're going to need the laws because the bases that you're working with are the same. So it's all about the bases here, they are the same. So it follows that if the bases are the same, like this situation that we are having, and you are multiplying them, you are going to add the exponents. Whenever you have this condition, you're going to add the exponents, which is the same if you are dividing this x to the exponent of m divided to x to the exponent of n, you are going to subtract the exponents, which is the same thing as you are given like this, x to the exponent of m over x to the exponent of n like this. Is still a division. So there you are going to subtract the exponents. So let us consider that maybe you're given x to the exponent of 9 divided to x to the exponent of 3. Maybe it's x to the exponent of 9 divided by x to the exponent of 5. Whatever that you're given there. It's a division. The bases here are the same. So what are you going to do? You are going to work with the exponents. So we are going to subtract the exponents 9 minus 3. That is x to the exponent of 6. We are done. So if you know the laws, it is going to be an advantage. All right, you're dealing with this part, you're going to subtract 9 minus 5, which is x to the exponent of 4. So meaning to say, if the laws are being applied, everything is going to be easier in the simplification. All right, so this is the second part that we're going to work with. Then also you need to know that every number, when it is being raised to the exponent of a 0, it is going to give us a 1. And also, if you are given this situation, maybe we have got x to the exponent of m, then there's another exponent outside of the bracket. You multiply the exponents together. So it's going to be m times n. So m times n, it's mn. All right. Then also on this same situation, let us just write this as A, then this as B. Maybe you've got a product of 2 terms, then there's an exponent that is outside. You are going to affect each and every term to that exponent. So it will be x to the exponent of m, y to the exponent of m. So this is based on the separation like numbers, 2 times 5 being raised to the exponent of n. It was taken from 2 to the exponent of n times 5 to the exponent of n. So you know that when it is like this, you can have it a reverse like this. When it is like this, you can work it like depending with the type of equation that you're working with. So an exponent, it affects everything. So if it is like this, that these are being raised to certain exponents, maybe this is x to the exponent of a, y to the exponent of b, to the exponent of m like this. What is going to happen? This is going to multiply. A is going to, remember here we said an exponent can be multiplied together. So it is going to be a to m. So that is going to be x to the exponent of am y and b, so it's going to be b versus m. You multiply b and m, so it's going to be y to the exponent of bm. That is the whole situation. So meaning you need to know this, you need to understand. All right, so it can be a division on the same part. Yeah, it can be, we are still on the same thing, all this part, still explaining the same thing. It can be also a division, x over y to the exponent of m. It is going to be x to the exponent of m. Y also will be raised to the exponent of m. So that is the situation that you're going to have there, which can be extended, guys, as long you have your laws, you play around the way that you want in any simplification. Then it also follows that if a number is being raised to a negative exponent, you remove this negative by the reciprocal 1 over. The reciprocal means 1 over. By just this 1 over, we have removed the negative. So if we have removed this, it means what is remaining? We are remaining with x to the exponent of m. So just to remove the negative, it's 1 over like this. So it's going to be x to the exponent of m. So the negative is no longer there. So it means if I'm given something like this, I can also have it as a reverse. Or if I am given it as a positive x to the exponent of m, I can write it this side as 1 over x to this one. It was a negative. Here it is a positive. So what does it mean? If this is a positive, this is going to be a negative. That is the situation. So this was a negative. Here it's a positive. So this is the situation that you have. Here it's a positive. So it means here it's going to be a negative. Positive, negative, negative, positive. The moment you introduce 1 over, this sign is going to change. The moment you introduce 1 over, this sign is going to change, just like that. Okay, so I hope with this, you can be able to answer any question. If there is anything, we are going to list that as we are moving on. All right, so these are the typical questions that you are being given in your simplification. Use laws, use exponent laws or index laws to simplify the following. So these are expressions which are actually exponents. These are exponents that we are having there. And in order for us to simplify these, we are supposed to use exponential laws. So I'm not going to answer everything, but we are going to try those questions. Then wherever you see that there is a challenge, we let us know so that we work those questions together on another class. All right, let us consider question number 1. Question number 1, we are given 2 to the exponent of 2 times 2 to the exponent of 8 divided by 2 to the exponent of 6. So if we check, we are just back to these laws, the multiplication, division concept. All right, so let me just save it this way so that we'll be able to see our laws. All right, so this is question number 1, where we are given to simplify this 2 to the exponent of 2, multiply to 2 to the exponent of 8, then divided to 2 to the exponent of a 6. So if I am to simplify this, I'm going to apply the laws now because I'm given these bases which are the same. We are in the base of 2. So what you consider there is the base which is the same. The base of 2, the base of 2, and also the base of 2 here. It is the same base that you are considering. So having the same base, it allows us to apply the laws. Whenever the bases are the same and you're multiplying, what are we going to do? We are going to add the exponents. So meaning to say this will be 2 to the exponent of 2 plus 8. But we are still dividing. There's a division there that is there. There's a division. So wherever there's a division, what are we going to do? You subtract the exponents. As long the bases are the same, you subtract the exponents. So meaning to say we are going to subtract this exponent of a 6. That's it. So this was going to give us 2 to the exponent. You can add 2 plus 8, that is 10, 10 minus 6, which is a 4, or you can just use your calculator. Then 2 to the exponent of 4 means 2 times 2 times 2, 4 times. 2 is multiplying itself 4 times, or on your calculator, you can just simplify this straightforward. That is going to give us a 16. So that is the whole idea there. So it is all about the laws that you are given. Number 2, we are given to simplify 2 to the exponent of 4 times 2. What is the exponent that is affecting 2? If the exponent is not given, it means there is a 1. If the number is invisible, there is a 1. Whenever you see the number invisible, it means there is a 1. So in this case, you are going to multiply, all right? That is 2 to the exponent of 4. So that's 2, you're multiplying, so you're going to add 2 to the exponent of 4 plus a 1, which is 2 to the exponent of 4 plus 1, that is a 5. So meaning to say, I've got 2 to the exponent of a 5. 2 is multiplying itself 5 times. So that is going to give us a 32. Or on your calculator, at this stage, you can just use your calculator. No one is going to know that you have simplified 2 times 2 times 2 by your head, or you have used a calculator at that final stage. What I'm trying to say is that you can simply do this on your calculator. 2 to the exponent, which is this part here, to the exponent of a 5 like this. So this is a 32. So that is how you can simplify the later stage. You are not supposed to use the calculator at the first stage. You can use it at the later stage in your simplification. All right, number 3, we are given 3 to the exponent of x plus 3 times 3 to the exponent of x minus 3. So this is what you're given on number 3. All right, so let us see this part here. I'm just going to try rewrite it here. Just hope it's going to be fine. Let me just move this part. Sorry for that, guys. So if we are to consider what we are given on number 3, we are going to simply use the first law, this one. All right, on number 3, we are given to simplify 3 to the exponent of x plus 3 multiplied to 3 to the exponent of x minus 3. This is what we are given, and we are asked to simplify using the laws of exponents. So considering the same situation that we had, we have got the base of 3, the base of 3, which are the same. And what is happening? You are multiplying these bases, which are the same. There is a multiplication. So what are we going to do? We are going to add the exponent. So meaning to say the exponents m and n, in this case, it is going to be 3 to the exponent of x plus a 3. You add this one of x minus 3. So in actual sense, whenever you're dealing with algebraic expressions, it is always best that an algebraic expression to be added or to be subtracted must be in a bracket. All right, though in this case of an addition, it does not affect anything, because if you expand, you're expanding by a positive 1. So this is not going to affect anything. It's a positive 1 times x, which is a positive x. A positive 1 times negative 3, that's a negative 3. So meaning to say at the end, by collecting our like terms, 3 minus 3, that's a 0. So you're left with x plus x, meaning to say this is 1x plus 1x. So 1 plus 1, that's a 2. So this will give us 2x. So that is 3 to the exponent of 2x. 3 to the exponent of 2x, you can leave it like that, or you can simplify this way. Remember, I say 3 to the exponent of 2 from this law here. If we are given a condition like this one, whereby you have got mn like this one, mn, this one, it means we can separate this. It was 3 to the exponent of 2 to the exponent of x, of which 3 to the exponent of 2 is 9 being raised to the exponent of x. So you can even leave it that way. Still one and the same thing, or you can just leave your answer at this stage. You are done. You are done. That is the idea there. All right. So these are the questions that we might be given in the simplification. You just need to work with as many questions as you can with the laws of exponents that you are having here. You can try to do as much questions as we can. All right, so like I said, I'm not going to answer everything that you're given. I want you to try question number 4. All right, question number 5, everything is being raised to the exponent of 2. So that means it's 2 to the exponent of 2, a to the exponent of 2, b to the exponent of 2. Everything is raised to the exponent of 2. So 2 to the exponent of 2, that is going to be 4a squared b squared. All right, so that was on number 5. Number 6, if we are to check here, we are given, let us try and have it here so that you can also see our laws. On number 6, we are given to simplify 8x to the exponent of a 0. Everything is being raised to the exponent of a 0. So remember the concept, xy to the exponent of m means everything is going to be raised to the exponent of m. So that is x is going to be raised to the exponent of m, y to the exponent of m. So this is 8 to the exponent of 0, x to the exponent of 0 also. So that is the condition there. Multiply to the same thing, that 2x is being raised to the exponent of 3, meaning to say we are back to the same thing that we have xy to the exponent of m. Everything is going to be raised to the exponent of m. So that means the 2 is going to be raised to the exponent of 3, and also the x is going to be raised to the exponent of a 3. Knowing that every number, when being raised to the exponent of a 0, is going to give us a 1. So that means 8 to the exponent of a 0, that's a 1, times x to the exponent of a 0, which is a 1, times 2 to the exponent of 3, like that one you can simplify on your calculator. That's going to be an 8 times x to the exponent of 3. So this whole part was going to give us 8x to the exponent of 3. Multiply 1 times 8, which is 8. That's the situation. So as long there is an exponent outside of the bracket, everything is supposed to be raised to that exponent inside of the bracket. So if you consider that, you are not going to have a problem. But take note, if it is an expression like this one, x plus 2 to the exponent of 2, it does not mean everything will be raised to the, like this, is going to be x squared plus 2 squared. No, this is wrong. This is an expression. It only applies if this is a term. Remember, a term can be a product. A term can be a fraction, not a sum like what we are given, not addition. This does not work. It's no longer applicable, this law. You have to expand, as usual, your brackets. It's only when it is under a product. That is an expression, under a product. So an expression, we are talking about under a product. All right, so that is the case there. On number 7, we are simply to apply the laws that are direct. 8a to the exponent of 2b, everything over 24a, b to the exponent of 2. So there we can simply apply our laws direct. And sometimes the laws, they are not even applicable sometimes. Like in this case, we can simply divide. We can simply divide. The 8 and the 8 is common. 8 into a, that is 1. 8 into 24, that is 3. Here, it's a, it's 1, which is a into a, that is a 1. A into a squared. How many a's are we having here? There are 2. So if we cancel 1a, how many a's are we going to remain with? We're going to remain with 1a. Here, there is only 1b. Here, there are 2 b's. So if I cancel this b here, in these ones, which are 2, how many b's am I going to remain with? I'm going to remain with 1b. So meaning to say, I'm simply going to multiply the numerators. What is there? 1 times a, which is a, over 3 times b, which is 3b. Just like that. So some of the cases, guys, you don't need to. All right, because these questions, what happens is that it will be just a normal question for you to simplify. And they will be just simplify. But if you have to use the laws of exponents now, that is when you have to apply your laws of exponents, this and that. All right, but those basic questions, prefer you just work them direct. All right, number 9. All right, number 8, you can just try this one, guys. I hope it's clear. Number 8, what does it mean? It means, remember I said everything, when it is like this, will be raised to this exponent of 3, which is outside. So it means the 3 is being raised to the exponent of 3. A squared is being also raised to the exponent of 3. Everything is being raised to the exponent of what? Of 3. The b to the exponent of 3, it is also being raised to the exponent of 3, which is outside of the bracket. Everything will be affected. So 3 to the exponent of 3, that is 27. a to the exponent of 2 to the exponent of a 3. We are now back to this law where we said an exponent, what happens? You multiply. If there is an exponent and there's an exponent outside, you multiply. So it's going to be m times n. You multiply the exponents together. So meaning to say, we are going to multiply 2 times 3, which is a 6. We are going to multiply on b to the exponent of 3 times 3, which is a 9. You're done. There's nothing that we can do from this part. So each and every part, it needs us to be very, very careful in our simplification. How are we going to simplify our given expressions? All right. So like I said, I need you to try as many questions as you can. Then we're going to have, we are going to have actually the part 2 of this. So make sure that you become part of this family, Meson African Motive, so that you won't miss any of the classes, and also join membership for more classes to come. Number 9, we are given minus 3x to the exponent of 2. So what does it mean? It means everything is being raised to the exponent of a 2. But whenever you are working with a negative, let us have this and conclude the part of a negative. If a negative number is being raised to an odd power, it is going to remain as a negative. If a negative number is being raised to an even power, it is going to be a positive. It changes to be a positive. Even numbers, remember even numbers, we're talking about 2, 4, 6, 8, and so forth. Odd numbers, if you divide by 2, you leave a remainder of 1. So these are 1, 3, 5, 7, and so on. These are odd numbers. So whenever you work with this, you're supposed to remember this. So meaning to say, a negative, when it is being raised to an even number, 2 is an even number, it is going to be what? It is going to be a positive. So there we are going to have a positive. 3 to the exponent of 2, which is a 9, x to the exponent of what? Of 2. So that is plus 9x squared. That is the idea there. So if you check now, you will see that on number 12, with the same situation, there is a minus 3x being raised to the exponent of 3, and 3 is representing what? An odd. So if you raise this to an odd number, it is going to remain as a negative. So we are going to have a negative. 3 to the exponent of 3, that is a 27, x to the exponent of a 3. So whenever you raise to an odd exponent, it remains as a negative. So these are the typical questions that you're going to have. I want you to try as many questions as you can. Then we shall have a continuation of the same activities that you have, but try to do as many questions. Where there's a challenge, let me know so that you can have those questions together in another platform.